I want to give groups an idea for worksheet 2 on the type of thing that I'm expecting for the Monopoly game. I've already demonstrated and given you access to Snakes and Ladders, which is a much simpler game than Monopoly. And some of the class diagrams and discussions I've had with groups about Monopoly suggest to me that they're going down quite a complicated route, or at least quite a sophisticated route, which is potentially leading to try and develop a full-blown game engine around Monopoly, which is allowing you to play the game. And that isn't really isn't kind of the level that I was going for here. So in a nutshell, and I'll write this down for the kind of visual learners amongst us, I want to implement the internal model or state of the game. So this is step 1. So we're not talking about interacting with the game, artificial intelligence, anything like that. We're just modeling the classes that have the state of the game. So imagine that you walking up to some people playing the game of Monopoly, and you have a piece of paper and you want to write down, okay, what is the state of the game at that time? What information would we need to capture the state of the game? And so it would be things like the who is playing, location of pieces, owners of properties, and money in the bank, something like that. So that would be, and if that was the level of detail that a group went to, that would be pretty good, really. So if you think about your classes that capture this, we're not worried about behavior at the moment, we're just capturing that information. And then the second part of this is we write tests that are, let's say, test scenarios that manipulate this state. So all the and so what we're doing is we're not managing a game of Monopoly, we're not playing a game of Monopoly, we're just doing things that manipulate this state, giving instructions. So things like new player joins the game, player moves location, or player pays money to bank. So we're not, for example, we're not expecting or hoping that every possible chance card, the outcome of every possible chance card is modelled. So what happens on the different chance cards, or every chance card is represented by a different class with a behaviour encapsulated in it. That's probably a bit too much. What we're going to do is we're going to write tests that cause these changes to the model state, and then we'll add the logic to the classes that allow us to manipulate that model state. So that's and then it's got step 3 is then to implement the tests and class logic to update the model state based on those scenarios. Okay, so that's what we're looking for. So what I'm going to try and do is I'm going to take my Snakes and Ladders game and I'm going to add something to it. Add a rule to it which is somewhat Monopoly-like. So what I'm going to do is, let's have a look. I'm just thinking off the top of my head here, but I'm going to allow, if you land on the top of a ladder, if you go up a ladder, then you can buy that ladder. That ladder can be owned by the person. Let's say that's what we're adding here. So let's do that. So we'll get, I'm going to create a separate branch here called owning ladders. Right. And so let's open this in a text editor. So what does this involve? Well, if we're doing a test-driven development approach first, what we would do is we would implement the test first. So I think that's in test resources. Here's our scenarios, our bhat scenarios. So not bhat, sorry, that's letting my PHP background creep through a bit. Our cucumber scenarios. So what I'm going to do is I'm going to add a new one of these. So let's just copy this one, save as, and we'll call this buying a ladder. So feature file, get rid of these. So the feature is can buy a ladder. Okay, first scenario is player lands on a ladder and buys it. Okay, so what have we got so far? So given we are playing a game of snakes and ladders, a player called Bob joins the game. Bob rolls a 5. Well, let's find out. Oops, I'm editing the wrong file here. That's the file I should be editing. There we go. So we want Bob to actually land on a ladder in this scenario. So let's have a look at this. Just snakes and ladders, that's the board I'm working with. So Bob will need to roll a 2, then he'll go up to 15, and then he can buy this ladder. Okay, so Bob rolls a, so we're having a game of snakes and ladders. A player called Bob joins the game. Bob rolls a 2, then when, hold on, let's say, and Bob rolls a 2, when Bob buys the ladder starting on square 2, then Bob owns the ladder. Well, let's switch it around. The ladder on square 2 is owned by Bob. So that looks like a good test to me. And that's the sort of thing you should be thinking about. So you can imagine for Monopoly, you can put in rules for going to jail. So Bob rolls a whatever, Bob lands on the go to jail square, then Bob is in jail or something like that. So we could write the test like that. Okay, so now the way that the next step here is I run Gradle Cucumber. So this is things you're being hopefully taught elsewhere, and what we see is it tries to run the cucumber test and it says, well, it's successfully ran some, but when it tries to run these, it fails, saying, okay, you've not written the code to actually implement this stuff, so you need to add this in, which is fine. So let me copy that, and where this goes is test model step definitions. I think that's slightly smaller. I'm going to put these at the put these right at the end, so we can just paste these in. So now if we run this test, we'll get slightly farther because these rules do exist. So it's not going to complain they don't exist. It's running them, but it's when it's running them, it's hitting this exception, which is fine, because what it's saying is, okay, I've created the rules for you. Now you need to do the work of implementing the logic to make these tests pass. So a couple of things I want to point out here is this has generated these tests for us, but we need to check that these tests are what we want. And you'll see here that this test, if it sees something where it says Bob buys the ladder starting on square 2, it's turning this number 2 in the end into an argument called arg1. That's okay, but also Bob here, that needs to be an argument too, right? Because we might want to run this test, or we might run this scenario where someone else is buying a ladder, not Bob. So this bob needs to be a parameter too. So the way that we do that is by taking our bob in this regular expression and converting this into something. We've probably got an example somewhere else. In fact, if we just do .star, it'll capture everything up until this buys, and it'll convert that into a parameter here, string and player name. And just for good form, I'm going to rename this argument square num. So when this argument, when Cucumber runs this scenario, what'll happen is it'll hit this line here. It'll say, haha, there's a rule I can fire here, or a step I can fire. And it calls this function and takes whatever we've put as the name of the player and whatever we've put as the square number, and it creates these parameters for us. And it's up to us now here to call the code in our software that will make this rule make sense. The other thing I'll do here, not necessary but helpful, is take the bob out of there and call it player buys this ladder starting on square. Okay, so this is where that's fairly formulaic now. This is where you need to start thinking slightly, is what functions can we call in our code base now to make Bob own this ladder? The problem is there's nothing really we can call because we haven't implemented the idea of ownership. But we can do that fairly straightforward. So if we go to model, so a ladder, if that had a, well, there's different ways we could implement this really. We could put in player owner like that. Let's try that. I'm not wild about this. I'm not wild about this approach because the ladder now is kind of aware of the concept of a player, which we're coupling these two concepts quite tightly. In some ways, I'd prefer to have something that was a some sort of ownership kind of database here, where perhaps we could have a map from snake to player called ownership new hash map. Just as someone who's developed a bit of software in the time, I like this approach better, that we're creating a separate relationship. It belongs to this idea of the ownership belongs to the game. It's not a property of the snake. But let's take this out, because I know that from some of the class diagrams I've seen, the ownership belonging to the property is something I've seen a lot of. So so here on a ladder we have a property called owner. Right. So in our, if we go back to our class here, so what we want to do is we want to get this ladder object, and then we want to set the owner on it. So how do we get the ladder object? Well, you'll notice that in the what have I done? When it triggers this rule, this we are having a game of snakes and ladders, which is the first step on our test here. We are having a game of snakes and ladders. So when we start a scenario, it'll fire this rule. It'll do this thing here, and it's setting this property, this.board, to be a new board. So it's kind of starting off the game. And so this.board belongs to the class stepdefs. So jolly good. So this property here is available to us. So here we can do this.board. Right, that exists. Fantastic. And so what we want to do is I want to create a player called buyer, and I want to create a ladder called property, and I need to get these somehow, these things, from the board, because it's the board that owns it. So we can probably see examples of this elsewhere. Here, when player rolls there, this other rule that's in there, we do something like this. We do board.players.get and then pass in the player name. So we can do that here. This is just because of the way that I've implemented this board game. There's this board concept or object, so it could be called game or whatever, but it represents the kind of the game, the state. And this board has a set of players, and when we add a player to the game, we add something to this property. And so, as when we in our test, when we did a player called Bob joins the game, hopefully you can guess that what that does is a player called something joins the game. We then, let's take that comment out. We take this player board.players property and we add a new player to it. So as we've done that, we've added Bob in our test. Now we can just get him back out again. Similarly with ladders, I'm not sure whether we have the ladders property here. Let's have a look. If I look at my board, I have got ladders. There's a property called ladders, and there's a hash map from integer, so the square number. So in theory, I should be able to do something like board.ladders.get square num. So that's got me the property. And then all I need to do is to do property.owner equals player. So I've now implemented the logic for this rule. So you could argue that I could move this logic inside one of my classes. So at the moment, this logic about buying properties isn't really part of my application. It's only within the test. And you could say, well, let's move that to board. And let's do that in a minute. But let's see if this works first. So we should see that first step working, and then the second step fails. Yeah, so only one step's failed. On step 177, which is down here. So it looks like this is working. We're managing to get the player to buy the ladder. Okay, so the next bit is this kind of final assertion. This test is that the ladder on square, whatever, is owned by Bob. Now we've got the whole Bob issue again. So let's turn him into a variable. Ladder square. Or what did we call it before? Square num. And we've got a string which is player name. As a hint for the eager amongst you, that if you find yourself frequently doing something like taking a variable for a player and then doing something to convert that to the actual player object rather than the string, you can do something automatic there. So we could write a bit of code that means that we could just do player there, and some code in the background is automatically wiring up the name that gets the string that gets passed in here into the player. But we're not doing that here, we're just getting the string, and we probably need to do exactly this thing here again. So we've passed in the square number and the player name, and from there, looking good. And we want to test that the owner of this ladder is in fact Bob, and so we need an assertion, and so we do assert true. Lots of different assertions we can do. We're going to do an assert true where we check that property dot owner is equal to player. So very, very simple here, that we in the setup thing, when we call this test, we are setting the owner of property to be the player, and then we're checking to see whether in fact that has worked. Let's give that a whirl. Bullseye. So you can see that that's worked then. We've not really written any code here, can you see? We've only added to the state of the application. We've not written logic for ownership or auctions or whatever. We've only just written some rules here that manipulate the state of the world, and then we've tested that that state is kind of working. Now, to go back to what I said before, that you might argue that, hold on, you've not actually written any application logic here, you've just put a property here, and all of your application logic is in your tests, and that's a bad thing. And you might be right. So what I'm going to do now, just to show you, is I'm going to move the idea of buying a property and put that into the game somehow. So let's put it on the board. The board is our kind of central thing for everything that happens. So we'll make a property here called public void player buys ladder, and that takes a player name, and it takes an int and start square. And in here we're just going to do exactly the same as we did before. So we've got the board, this is this dot players dot get player name, and we'll do list dot ladders dot get ladder start square dot owner equals. So that looks logically right. So we're getting the ladders out, we're setting the owner to be the player. Let me just check that that compiles. I'm sure it'll compile, but then I'm sure that, oops. Yep. Go on, Gradle. Right. I think it'll compile, but then if we try and check it, then check style will complain about the it's complaining about the rule violation. So you can probably guess what these rule violations are. I've not put a space in there, I've put an extra new line in there. That's at least two problems. The fact that this only has one line of, I've just a semicolon there, haven't I? There we go. The fact that this only has one line in it means that check style might forgive me in not having javadoc there. We'll find out. Yes, no, check style hasn't forgiven me. It's not giving me a clue as to what is the problem. So let me cat that file. Okay, some problems here. Missing javadoc comment, yes. Line is longer than 100 characters, it doesn't like. Missing javadoc, okay. So it's reporting two things here. It doesn't like the length of this line, so let's truncate it. Let's write some javadoc. So set ownership of ladder, full stop, param player name, name of the player, full stop, ladder start square, okay, let's see if that makes it any happier. Looks like there was two problems here, so I might have another problem. So this is on line 114 and 105. Oh, it wasn't in that file actually, it's in step defs. Let's take a look at step defs. Oh, it wants javadoc for these things. Okay. So this is why This is why check style can make you crazy, because it's constantly slowing you down when you're developing, but that's part of quality. So this is ladder owned, check ownership of ladder. So we've got square num square, then it will also complain about that. Here we're going to set the ownership of the ladder, and they're the other way around. Can I swap them around like that? Yep. I noticed also that we've got Bob in here. I'm going to change that to player. You can call these methods whatever you like, but let's keep them nice. Right, let's try again. Right, still got rule violations. So we're talking about line 112 and 127. Oh, let's see. Okay, so the method names are too long. That's interesting. Play bys ladder. Let's call this play bys ladder. We'll call this one ladder. One by player. Right. Try one more time. Right, okay, we've now got code that's right. The other thing we need to do is, now that we've got this method called, so on a board we can set the ownership. Let's have a look at that one more time. Player bys ladder. In our test step, instead of manually doing this, we can replace all of this with board.player bys the ladder. No, that's not right. It is called player bys ladder. And we pass in a player name and a square number. So player name square num. Let's try that. Right, everyone seems happy with that. And we'll do Gradle, cucumber. And that's still working. So now we've moved some of that logic into our application rather than it all being in the test files. So hopefully that gives you a flavour of the type of thing I'm expecting. So other tests might be for this. So we could, for example, say, we could repeat this test and say second player lands on the ladder and buys it, and then we could have someone else landing on this ladder and trying to buy it, and then somehow the system then causes an error. But again, we're getting into the managing the playing of the game, managing the rules of the game, rather than manipulating the state of the world and checking that we can manipulate the state and the state actually gets updated, which is what we're trying to do here. Only because we're narrowing the focus of this worksheet. So we're not generating a rules engine, we're creating the state of the game and then rules that manipulate that state and check that the state is then valid. So hopefully that clarifies the type of thing that I'm looking for and gives you some sort of clue as to how that can be implemented.